A body in a two-dimensional projectile motion is shot at an angle to the horizontal. So it is given an initial velocity u or v at an angle theta to the horizontal. And when it is shot in that manner, the body starts from whatever it begins from, gets to a maximum point and then drops to the ground. And so here we are looking at ground starting from here and then dropping to the same level or ground. So this is ground to ground. Okay. This is the maximum height traveled by the body. The maximum vertical height traveled. And so we said that let this be h, the maximum height be h. Now, because it is shot at an angle, its initial horizontal component u cos theta, its initial vertical component, this is ux. Y is equal to u sine theta. All right. Then last time we observed that horizontal component, if we look at x analysis along the x-axis or the horizontal component, along the horizontal component, we realize the velocity is constant. So initial horizontal velocity is equal to final horizontal velocity, and they are all equal to u cos theta. And what is the reason for this constant velocity along the horizontal? Yes. Can somebody remind us what is the reason for this constant velocity along the horizontal? Yes. We are recapping, so let's be quick. If you are ready, please share with us quickly. What's the reason for this constant velocity horizontally? Oh, let's not waste time. Okay, Adwa Otubia Asante. What is the reason for the constant velocity horizontally? Oh, Adwa, are you there?
Yes, please.
What's the reason for the constant velocity horizontally?
His gravity has no effect on.
That's one. The gravity has no
That is
effect. Good, because the key reason is that air resistance is neglected. Okay, and gravity has no effect along the horizontal axis. So U is this. Now we saw that the displacement at any time t of the body x is equal to the constant velocity u cos theta times any time t. And when we look at the maximum horizontal distance traveled during the complete flight, this value is known as the range. And so we got that the range is equal to u cos theta times the time of flight. And the time of flight is the total time taken during the complete flight of the body. Okay, so this is the velocity analysis. This is the expression for the horizontal displacement. Now, what is the acceleration of the body along the x-axis or horizontally? What do we say about the acceleration of this body along the x-axis? Quick one. If you are ready, share that with us. What's the acceleration of the body along the x-axis? Hello. What's acceleration? Nanepia, what's acceleration?
0.
So that is 0. Nanepia, why? Because
Because when there is constant velocity, acceleration is 0.
thank you. Then let's look at the vertical analysis of the motion, or what happens along the y-axis. Along the y-axis, this time gravity is the master there, and so we cannot eliminate gravity. So because of gravity, the vertical velocity of the body is reduced as vertical velocity of the body is reduced with time. So it changes, decelerates. So initial vertical velocity, uy, which is giving us u sine theta. But if after any time t, the vertical velocity becomes u sine theta minus gt, meaning as time increases, this velocity also decreases. So this is the expression for determining the vertical velocity after any time t. What if the velocity decreases? Then what is the acceleration of the body vertically? Nana, what is the acceleration of the body vertically? What will you say about the acceleration of the body vertically?
It will be decreasing.
So it's negative. What is the vertical displacement after any time t? Using s, let's use h, because the vertical height, we use h. Using h is equal to uy t minus half j t squared. We can determine the vertical velocity, vertical displacement. Uy is u sine theta minus half u sine theta times t minus half j t squared. And so this is what we got for the expression for the vertical displacement of the body after any time t. Please, we are just recapping. Okay, this is what we deduced last time. But all right, so we've discussed the velocity, acceleration, and then displacement. Then we obtained some standard values. We saw that under projectile motion, as the body journeys on, when the body is here, before reaching the maximum point, the horizontal velocity is always constant. It doesn't change. U cos theta. But the vertical velocity changes with time. And that is u sine theta minus dt. This is Vy. When the body gets to the maximum height, the vertical velocity is 0. Vy is equal to 0. But the horizontal velocity at any time is constant. U cos theta. When it gets to this point, yes, horizontal one is constant, but this one is u sine theta minus upper dt, on and on and on. So when the body gets to the maximum height, The vertical velocity is 0, but there is a horizontal velocity acting on it. So if I ask you, what happens to the body when it gets to the maximum height? To say that the velocity is 0, I won't accept. But I will accept, okay, the explanation that at the maximum height, the vertical velocity is 0, but the horizontal velocity is constant. That I will accept. Please, are you okay with me?
Yes, please.
Good. So if at the maximum height, Vy is equal to 0, then we can obtain a very important formula for the time taken to reach the maximum height. When the body starts from here, the time taken to get to the maximum height. Vy is 0 at the maximum height. So at the maximum height, Vy is equal to 0. If, hey, you are not seeing yet, you haven't drawn my attention. If Vy is equal to 0, then using Vy is equal to u sine theta minus dt, this is 0. 0 is equal to u sine theta minus dt. If we make t the subject, we have u sine theta over d. And this is the time taken to reach the maximum height. Please, are we fine? Now, what is for the formula for the maximum height itself? What can we represent for the maximum height itself? For the maximum height, we could see that at the maximum height, yes, Vy is equal to 0. So when we use this equation, V squared is equal to U squared minus 2JH. Now, our U initial vertical velocity is U sine theta. So when we put that in and square, we are saying at the maximum height, the vertical velocity is equal to 0. So this is Vy squared. So we put 0 for this because we are at the maximum height. Then this would help us get equation for the maximum height reached by the body. It means that H max, which is the maximum height, and that's what we have represented by the letter H. H is equal to U sine theta all squared over 2G, or U squared sine theta squared, we also write it as sine squared theta over 2G is the maximum height. Please, I hope we are following. I hope we are following.
Yes, please.
Okay, now, what equation did we get for the time of flight? The time of flight, capital T. Come again. So, capital T, which is the time of flight, is 2U sine theta over G. There is another way out in determining the time of flight, which I want to take you through. And that is it. Let me adjust the screen to this side. When the body gets, let's look at the diagram. When the body moves from this point, okay, from here and then drops back to the ground, from ground to ground, what is the value of the vertical displacement of the body? When it drops back to the ground, what is the value of the vertical displacement of the body when it is here?
0.
It's 0. Okay. So look at something. So when it drops, when body or the projectile drops to the ground, when it drops to the ground, H is 0. Okay. If H is 0, then when we use this formula, H is equal to U sine theta t minus half JT squared. We can get something. And look at it. When the body drops back to the ground, the time taken, okay, the time taken from the body starting to when it drops to the ground, that time is known as what? The time taken for the body to start and then drop back to the ground is time of flight. Good. Is the time of flight. So over here, if H is 0, that means we are on the ground. Then all the T here must change to time of flight. It must be capital T minus half J capital T squared. Okay. Let's this is negative. When we send it to the other side of the equation, we have half JT squared is equal to U sine theta times T. Please, I want you to make T the subject from this equation for me. Make T the subject from what we have on the board. What did you get for T? What did we make for T?
Instead, yeah.
Yes.
Please, I don't know if what I had is correct.
Oh, you are just making T the subject from this relation. So go ahead and share with us.
Okay, I got sine theta all over G.
Look through it again.
Oh.
Okay. If you got something different, you can share with us quickly. Okay, so from what we have here, I'm making T the subject. So if I divide through by T, this and this will cancel. And this is 2. This will cancel one of it. Okay, so we have half JT is equal to U sine theta When we multiply through by 2 times 2 times 2, we have dt equal to 2u sine theta. So now when we eventually divide through by j, we have t is equal to 2u sine theta over j. And so this is giving us the same equation we got for the time of flight. Okay,
Mr. Ejia,
so it means, hello,
please, that's what I got.
yes. So next time, feel free to share it. Okay, we are learning. Don't, I mean, be shy of mistakes that can possibly be done. It's part of learning. Okay.
Yes,
So
please.
when the body drops back to the ground, the vertical displacement is 0, and you can use the equation for the vertical displacement of the body to find the time. Okay, there. All right. We'll come to another equation, another simplified equation under projectile motion. But before then, enough. Let's rest a little bit from the equation. I'm going to give you, we are going to solve a question. We are going to solve a question. Let's see how we can apply the formula to solve problems under projectile motion. Okay.
Mr.
All
Ejia,
right. Hello.
please, when did you start the class?
Last week.
No, like as in today. This, like, because when I joined, you had written a lot on the board.
Okay. It was, I think, I can't, but we started about 10 minutes after the actual time. Yeah.
Oh.
We're actually reviewing. Okay, I'm dictating a question, so please get ready to put it down. A small missile is fired with a velocity of a small missile is fired with a velocity of 300 meters per second. A small missile is fired with a velocity of 300 meters per second at an angle of 30 degrees. At an angle of 30 degrees. Can I continue?
Yes, please.
At an angle of 30 degrees with the ground. With the ground. The ground is a horizontal. After a total flight time of 30.6 seconds, after a total flight time of 30.6 seconds, the missile returns to the level ground. After a total flight time of 30.6 seconds, the missile returns to the level ground. Into bracket, neglect air resistance. Into bracket, neglect air resistance. A. Determine the initial horizontal and vertical components of the velocity. Determine the initial horizontal and vertical component of the velocity. B. B. Determine the maximum height of the missile above the ground. Determine the maximum height of the missile above the ground. And C. Determine the horizontal range of the missile. C. Determine the horizontal range of the missile. So the questions are: determine the initial horizontal and vertical component of the velocity. B. Determine the maximum height of the missile above the ground. And C. Determine the horizontal range of the missile. Take gravity to be 10 meters per second squared. Take gravity to be 10 meters per second squared. So I'm giving you 5 minutes to play around. Let's see what you can do. Then after the 5 minutes, I will come in to solve it with you. Is that okay?
Yes, please.
All right. So this is the problem of the afternoon. I am going for commercial break. I'll return in 5 minutes time. So we are told that a missile is fired with a velocity of 300 meters per second. So the velocity given to the body U is equal to 300 meters per second. At an angle of 30 degrees with the ground. So this velocity makes an angle of 30 degrees with the ground. This is the ground. The horizontal is the ground. Now, after a total time of flight of 30, a total flight time of 30.6 seconds. So here the question has given us the time of flight, 30.6 seconds. The missile returns to the ground. So ground to ground. After time of flight of this 30.6 seconds, the missile drops back to the ground. So, okay. Determine I, the initial horizontal and vertical components of the velocity. Yes. How do we find the initial horizontal and vertical velocity? Initial vertical velocity. Yes. Somebody to share how you calculated for this with me. Anybody? Yes. If you are not ready, I'll call you. Yes, who is ready to share with us how the initial horizontal and vertical velocity is calculated? Yaba?
Xavier, please, the initial vertical velocity equal to u sin theta.
So Yaba is saying that the initial vertical velocity is equal to u sine theta. So we just substitute the values, not what you are saying.
Yes.
So 300 times sine of 30 would give us that. And sine 30 is equal to half. So this is equal to 150 meter per second. Thank you, Yaba. Then what about the initial horizontal velocity, ux? Yes. Yes, how do we calculate for the initial horizontal velocity? Hey, I'll call you. I'll go ahead.
It will be u cos theta.
U cos theta. And we know u, we know theta. So 300 times cosine of the angle 30. Cos 30 is root 3 on 2. So this is 150 root of 3 times root of 3. Or 300 times 0.866. And that is 300 times 0.866 is equal to what? Oh, give me the final answer.
159.81 meters per second.
Come again.
159.81 meters per second.
Thank you.
Instead,
That's-
this is
that-
259.
1 and 2, 2, 259. Okay. That's it. Okay. Then the next question. B. Determine the maximum height of the missile above the ground. Yes, we have to determine the maximum height of the missile above the ground. So here, I wouldn't want Yaba and Adua, they helped us in the first two. I want somebody else to share with us how to calculate the maximum height. Yes, who is ready? Before I call. Who is volunteering that for us? Oh, please, it's the same formula. And please do not be worried about making mistake. Just share with us what you think. If it's correct, that's it. If it's not correct, we learn and then move on. Okay. Yaba, let somebody, okay, I want somebody else to try before. Okay. We shouldn't worry about mistakes. It's part of learning. Okay, Addison, let's go.
Maximum height equal to u sine theta square over 2g.
Excellent. Okay, H is equal to u sine theta squared over 2g. So that's the formula we derive for the maximum height. So, and look at a funny thing. We have already found u sine theta, 150. So it means this is just 150 squared over 2 times gravity. Okay. So square 150 divide by 20. What's the answer?
1,125 meters.
1,000.
125 meters.
Oh, your line is fading.
1,125 meters.
1,000.
125
125.
meters.
That's all. So it's not difficult. It's not difficult at all. It's not difficult at all. Then the last question, determine the horizontal range of the missile. How do we get that? Determine the horizontal range of the missile. Liz, let somebody also come in, okay? Thanks for the attempt. I want a different person, not Lizzie, not Yaba, not Adwas Otubia. Already,
Sir, please, R is equal to rho cos theta times T, capital T.
exactly. Okay. And we found U cos theta. U cos theta, we got 259.81. So 259.81 times, the question gave us the time of flight, 30.6. So put them together and share with us what the results will be. That one. Okay, no. All right. Okay, I raise your hand.
Please, it will be 7,950.186 meters.
So approximately 7,950.2. Or here you can even run it to the nearest whole number. So that's projectile motion question. Class, is it so difficult? To the house, is it so difficult?
No, please.
The formula involved looks, but it isn't so difficult. I'm going to give you another question. Okay. Okay. Are we ready? A particle
Yes.
is projected 29.4 meter per second at an angle of 30 degrees to the horizontal. A particle is projected at 29.4 meter per second at an angle of 30 degrees to the horizontal. Calculate A, the total time of flight of the particle. Calculate A, the total time of flight of the particle. Then B, the speed of the particle at its maximum height. Then B, the speed of the particle at its maximum height. Take gravity to be 10 meters per second squared. Start with 5 minutes.
Mr. Edia, please, can you go over again?
Okay. A particle is projected at 29.4 meters per second at an angle of 30 degrees to the horizontal. At an angle of 30 degrees to the horizontal. Calculate A, the total time of flight of the particle. the total time of flight of the particle. Then B, the speed of the particle at its maximum height. B, the speed of the particle at its maximum height. Take G to be equal to 10 meters per second squared. So 5 minutes again. So this time we have the particle is projected at a velocity of that. So horizontal, the angle of projection is 30. The body is given a velocity of 29.4 meters per second as the velocity of projection. Once it is projected at an angle, it will have that parabolic trajectory or path. We have to calculate A, the total time of flight of the particle. And it is starting from the ground and then at the ground. So ground to ground. We know that the time of flight, capital T, is equal to 2 times u sine theta over J. Okay. So since we have u, since we have theta, 2 times 29.4 times sine of 30 divided by 10. So that is it. Sine 30 is 0.5. So this will give us this will be equal to 2 by 29.4 times 0.5 divided by 10. The rest is calculation. So what did you get for the time of flight? Yes, what did we get for the time of flight?
2.94 seconds.
Okay, so T is equal to 2.94 seconds. Let me confirm two. Please, let's all confirm to be sure of our values, okay?
Yes, please.
Yes, so it's correct. Then the second question. What is the speed of the particle at its maximum height? Yes. How did you calculate for this? What's the speed of the particle at its maximum height? Let me have contributions from you. Okay, Akosia Adoma.
First, since we don't know the maximum height, you calculate for it.
Mm-hmm.
And then you use I don't know if that part is correct.
Akosia, I'm just analyzing what you are doing. Then afterwards, I'll also come in. Okay. So you want the maximum height. Well, after getting the maximum height, what will you do with it?
I put it in the equation v squared is equal to u squared minus 2gh.
V squared is okay. So you got something. You got a value, right?
Yes, please.
We shall see if it's the same value. Yes, I can see another hand. Please go ahead and share what you have with us.
I found the vertical speed and then the horizontal speed separately. So
You found the what?
the vertical speed, that one will
And
be 0 meters per second.
mm-hmm,
Then the horizontal speed is constant, which is equal
mm-hmm.
to u cos theta,
So what's the speed?
25.5 meters per second.
Okay. I think I have somebody else.
Mr. Dia, that's what I also.
Okay. So you see, here the question is saying that we have to find the speed of the particle at its maximum height. And we know that in projectile motion, when the body gets to the maximum height, the vertical velocity, when the body is here, the vertical velocity Vy is 0. The horizontal velocity is constant. What it means is that when the question is demanding the velocity at the maximum height, it is just the constant horizontal velocity. Because the vertical one is 0. And so only the horizontal one survives, or it's what is available. So the velocity of the body at the maximum height is equal to the constant horizontal velocity. That's all. So when you here you have to calculate V at the maximum height is equal to u cos theta. So 29.4 times cos of 30 degrees. And this is 29.4 times 0.866. Okay. I also want to confirm. So 29.4 times 0.866, and it's 25.46 meter per second. Please, are we fine?
Mr. Dia,
Yes.
Uh,
Mr. Dia,
hello, Lizzie.
please, I wanted to ask a question.
Go ahead.
When you are solving for it, is it compulsory to draw?
Oh, the drawing, I mean, gives it a clearer, okay, outlook. Okay, this is just a sketch. So it's better when you bring the sketch and then, okay. But
Okay,
if you don't bring, if you don't sketch and you are getting the values right, it is equally correct. But it's nicer when you have something like this as part of your analysis. Okay.
okay, thank you very much.
Okay. So that is the whole nitty-gritty about projectile two-dimensional projectile motion. Now, there are in the books, there are some other formula apart from what, okay, we have. Range is equal to u cos theta times the time of flight. The time of flight is equal to 2u sine theta over j. So if time of flight is this, then I can substitute this in place of t within the time of flight, within the range formula. So I can have this. R is equal to u cos theta times, now time of flight is this, 2u sine theta over g. When I put this together, I have 2 u times u squared sine theta times cos theta all over g. This is another formula for the range. I can also simplify this to make it simpler. If you look through the books, you will see this. You will see this. That's why I want to clarify for you. Now I can still make this simpler, and this is how I'm going to do it. Range is equal to u squared over g 2 times this, 2 times sine theta times cos theta. Okay, so all that I've done is that I'm repeating u squared dividing by g, but this 2 comes over here to multiply sine theta cos theta. Please, are we okay?
Yes, please.
I'm going to also look for a simple equation, simple formula for this. This looks so weird or long for me. I'm going to get an equation that is equal as this to put it in to simplify this. So pay attention and then fasten your seatbelt. Okay, to be in flight with me. Now, in trigonometry, and trigonometry is about measurement of triangles. In trigonometry, if you have what we call compound angle, and when I talk about compound angle, this is it. I have, if I write cos of theta, this is a simple angle, one angle, and I'm taking the sine of it, cos of it. If you have 2 different angles, maybe alpha and theta, so we have cos of theta plus alpha. Theta is a different angle, alpha is a different angle, and so this is a compound angle. Compound because we have 2 different angles. Please, is that okay?
Yes, please.
In the same way, I can have sine of it, sine of a compound angle, theta plus alpha, tangent of it, theta plus alpha, and these are what we are calling as compound angles. Now, if I have sine of a compound angle, the angles are theta and alpha, adding. It can be plus or minus. Okay. If the operator is plus, the operator can be plus or the operator can be minus. That's why I have here plus or minus. The expansion, if I want to expand this, the expansion of this is equal to sine of the first angle, theta, times the cosine of the second angle, alpha. Plus or minus, depending on what you have here. Here I need, let me maintain my plus. Plus. Then, you see, in the first term, sine took theta, cos took alpha. In the second term, they will swap. So this time sine will take alpha, sine alpha cos theta. That's the expansion of this. Cosine has its formula too of expansion. Now you realize that, so this is the expansion of sine theta plus alpha. Now, when the angle, the two angles is double the same, sine theta plus theta, and here they are the same angle. So this time around, because they are two, theta plus theta is equal to 2 theta. So this is equal to sine 2 theta. We term this as double angle, whereas this is compound. This is 2 times of the same thing, so it's double, hence double angle. These are different angles, so compound angle. So when you have the same angle, a double angle, which is theta plus theta, the expansion of this is the same thing according to this the same formula, but this time the angles are the same, so alpha will be theta. So we have sine theta cos theta plus sine theta times cos theta for double angle. And this is the same as this. So what we have here is the same as x plus x. Okay. And since x plus x is equal to 2x, this will also give us 2 sine theta times cos theta. Meaning if you have a double angle, sine 2 theta is the same as this. Please, are we okay? Are we okay? Now, let's look at our range formula now. Look at it. We got the range to be equal to u squared over j times 2 sine theta cos theta. What is here is the same as what we got here. So in place of this, we can put this. So because this is the same as this, range can be simplified to be u squared over j times sine 2 theta. This is another formula for the range. So the range actually can be expressed as this, but this is the same as this one. Okay, and this is simpler. Okay, now let's look at one of the questions we've just solved, which demanded that we calculate for the range and use this. Which of the questions require that we calculate for the range? Is it the first one or the second one?
Is the first one.
The first one.
Okay. In the first one, give me what the initial velocity, the value we were given as the velocity of projection. That was, I think, 300.
Yes, please, 300.
300 meters.
So u 300 meter per second, and then we're also given a time of flight, right? Okay, I think we're given the velocity of the angle of projection theta to be, is it 60?
30.
In the first question.
Yes, please.
Okay. And gravity we're asked to we're given as 10 meter per second squared. We are required to calculate for the range. And so Range, if we are using this, range is equal to u squared over g times sine of 2 theta. U squared is u is 300, so 300 squared times sine of 2 times theta 30 divided by 10. So this is 90000 times sine 60 divided by 10. This is 9,000 times 0.866. 9,000 times 0.866. And our answer is 7,904. That's 7,794. So R is equal to 7,794 meters. What did we get for the range in the question? The earlier question we saw, what did we get for the range?
We got 7,950.
7,950.
50.
No,
Yes.
it's
I have 7,750. Oh, I'm listening.
7,950.
Here the difference is huge. Okay. I'll check to see why the difference. But this is the other relation for determining the range. Okay. Now let's look at maximum range. We have range, we also have maximum range. What is maximum range? If the body is projected or thrown, okay, different angles would give different maximum horizontal distance to travel. Look, the range formula is equal to u cos theta times the time of flight. What it means is that the range is directly proportional to the initial velocity, the velocity of projection. The same range is also directly proportional to the cosine of the angle of inclination theta. And lastly, the range is directly proportional to the time of flight. This relationship tells me that when you increase the velocity of projection u, it will affect how much the body will travel horizontally, which is the range. So if I want more range, more horizontal distance covered, I can do that by one, increasing the velocity. I can also do that by changing the angle. Okay, the angle of projection. Different angles of projection give me different horizontal distance travel. And then the range is also affected by the time taken to make that complete journey. Different time of flight will give me different range. So these are the factors on which the horizontal distance traveled by the body depends. Please, are we okay? Are we okay?
Yes, please.
Good. If R is directly proportional to cosine of the angle, meaning different angles would give me different horizontal distance. It means that if let's assume I'm increasing. Give me a second, I'm coming. There's light out, so let me bring natural light into the room. Hello, can you hear me?